Hi there. My name is Sakib Kazi from the University of Ottawa. I'm here today to speak about our group's recent publication in the Journal of Magnetic Resonance Imaging. Our study is titled Evaluating the Impact of Peer Review on the Completeness of Reporting in Imaging Diagnostic Test Accuracy Research. This presentation will provide a high-level overview of our project and findings. You can find further details in our full published paper. I would like to acknowledge the efforts and contributions of everyone who is listed here that was involved in our project. I'd also like to start off by acknowledging some of the grant support that we received for this project, namely from RSNA Research and Education Foundation, from the MyTax Research Training Award, and from the University of Ottawa Department of Radiology and the Undergraduate Research Opportunity Office. To provide some background, peer review is the process of subjecting scientific reports to scrutiny and expert critique. It is a mainstay of biomedical research. It is widely considered an essential element to ensure publication of only high-quality research that can be trusted. Although the efficacy of peer review is not well understood, some of the expected functions of the process include quality control and improvement of manuscripts. Despite the nearly ubiquitous reported use of peer review among reputable, non-predatory medical journals, the reporting and interpretation of biomedical research remains suboptimal. This raises the question, is peer review actually working? The purpose of this study was to evaluate whether peer review of diagnostic test accuracy studies published by imaging journals is associated with improved completeness of reporting, improved transparency for risk of bias assessment, and decreased spin of results. For those who may not be familiar, spin is also commonly known as overinterpretation and is a reporting practice in which study conclusions are more optimistic about a test or intervention than is justified by the results of the study. With regards to the screening, articles were screened from the Journal of Magnetic Resonance Imaging, JMRI, the Canadian Association of Radiologists Journal, CARJ, and European Radiology, all of which endorsed the use of the STARD 2015 guideline. Furthermore, studies were screened consecutively in reverse chronological order from March 31st, 2020. Studies were included on the basis that they were primary studies evaluating the diagnostic accuracy of an imaging test in human subjects. Studies were excluded if they exclusively reported on the accuracy of a prognostic or predictive test, or if they were systematic reviews. As determined by power analysis, a minimum of 23 articles were included per journal. Each manuscript was assessed and scored independently by two investigators. Both the initial submission and final accepted revision for a given study were assessed by the same pair of extractors who were blinded to the version being assessed. Completeness of reporting in the initial submission and final accepted revision were evaluated based on the adherence to the STARD 2015 and STARD for Abstracts guidelines. The Standards for Reporting Diagnostic Accuracy Studies 2015 statement, also known as STARD 2015, provides a list of 30 essential items as a reference, with a separate dedicated checklist for abstract reporting, known as STARD for Abstracts. Transparency of reporting for risk of bias was evaluated based on a modified version of the QUADAS-2 tool. QUADAS-2, standing for Quality Assessment of Diagnostic Accuracy Studies 2, is a complementary tool for appraising the quality of diagnostic test accuracy studies in terms of risk of bias and applicability, which this relies on detailed and transparent reporting of study methodology. Finally, actual and potential spin in the initial submission and final accepted revision were evaluated using pre-specified criteria, which were adapted from prior studies based on expert consensus. With regards to the statistical analysis, a Shapiro-Wilk test was performed to assess for normality. If a normal distribution was confirmed, comparison of scores between initial submissions and accepted revisions were performed using a two-tailed paired t-test. If a normal distribution was not confirmed, comparison of scores between initial submissions and accepted revisions were performed using a paired Wilcoxon signed rank test. In total, 692 articles were screened, of which 84 were included. Out of the 30 essential items in the STARD 2015 checklist, initial submission versions reported a mean of 16.67 items, compared to accepted final versions, which reported a mean of 17.47 items. The increase of 0.8 reported items between initial submission and final accepted revisions was statistically significant. Out of 10 essential items in the STARD for abstracts checklist, initial submission versions reported a mean of 5.28 items compared to accepted final versions, which reported a mean of 5.25 items. No significant difference was found for the reporting of STARD for abstracts. Out of 10 essential signaling questions in the modified QuADIS-2 tool, initial submission versions reported a mean of 6.08 signaling questions compared to accepted final versions, which reported a mean of 6.11 signaling questions. No significant difference was found for QuADIS-2. Out of the 13 criteria for actual spin practices, initial submission versions reported a mean of 2.36 practices compared to accepted final versions, which reported a mean of 2.40 practices. No significant difference was found for actual spin practices. And finally, out of 6 criteria for potential spin practices, initial submission versions reported a mean of 2.93 practices compared to accepted final versions, which reported a mean of 2.81 practices. No significant difference was found for potential spin. Since this study considered only papers from 3 radiology journals, the results are not necessarily generalizable to other journals, other fields of diagnostic test accuracy research, or other study designs. Furthermore, there are also some important limitations regarding the use of these checklists. Firstly, the weighting of items was not necessarily proportional to their importance, where a sub-item worth only fractional points in our analysis in practice may be much more critical to report compared to a less essential item that is worth a full point. In conclusion, peer review is associated with a marginal improvement in completeness of reporting in published imaging diagnostic test accuracy studies, but not with a significant improvement in transparency for risk of bias assessment or reduction in spin. Studies are often accepted for publication despite suboptimal completeness of reporting, transparency of reporting, and spin of study results. Ultimately, further research is required to determine whether targeted interventions may increase the impact of peer review on study reporting, which may in turn optimize the quality of published literature that informs clinical decision-making. Of note, this study builds on prior work within the realm of editorial practice by our team, which has also been published in the Journal of Magnetic Resonance Imaging. Please feel free to take a look at this study as well. Thank you.